Okay, welcome everyone to TAM Lab number 64. Today we've got Andy Schneider joining us. He's going to be showing us some cool stuff around automating NSXT with Terraform. So I'm going to hand it over to Andy.
All right, thanks, Steve. Hopefully you guys can see my slides all right.
Yep.
Yep.
Perfect. All right, thanks everyone. Excited to be here today to talk to you a little bit about how I'm utilizing Terraform CLI in my lab to automate NSXT DevOps style. So a little bit of background about me. I've been a network and security guy my entire career. And so what I'd really like to point out is this isn't just for your typical developers and programmers. I think anyone can do this, and that's one of the points I want to get across today, is to encourage you to try this. It's not overly difficult, it's not overly complicated. You can certainly start small and grow from there and iterate over time. So I'm going to start today just very briefly talking about what is DevOps in this context. Share with you some of the NSXT automation options you have out there and where Terraform fits in. We'll go over some basics of Terraform just to set the stage for the demos. Then I can go through 3 demos that are going to be increasing in complexity, just to demonstrate how you can get started and grow over time. And then finally, I'll give you some tips on where you can go for finding more info. So, you know, in the old world where we did everything via the GUI or via the CLI, certainly there's a better way of doing it, and DevOps is one avenue of completing that by developing infrastructure as code. It allows us to create templates, automate things, and also encourage reusability and consistency. And so, you know, without DevOps, we're kind of stuck in the age of being stuck on an island with Wilson and waiting for things to get done. So why DevOps with NSXT? Like I said, that allows us to deploy things rapidly, but also consistently, right? Without error, without human error, hopefully. Deploy broadly. So one of my labs today, I'm going to show you how I'm using NSXT to deploy to multiple sites at the same time. So if you've got a use case where you're trying to create consistent policy across many NSXT deployments, this could be one option for you. And I think very importantly, the third one, the capability of being able to roll back quickly and guarantee that your configuration state is rolled back to the previous state. It's an extremely powerful concept, and DevOps with Terraform enables that. So just a little primer on DevOps and the like. So we think of DevOps, we think of a cycle, or down below on the lower left, you see the DevOps infinity loop, a release cycle, right? Dev, QA, and prod. We think of utilizing a version control system in order to keep our code up to date and synced across multiple developers. Certainly, we think of utilizing automation to make our lives easier. And then lastly, deploying often or iterating on our code and making small changes over time to effectively update our code. So DevOps is certainly a large topic within the industry, but narrowing in a little bit, we have what's called GitOps. And this was a term coined to sort of talk about a specific focus around using Git as our version control system, and then utilizing automation pipelines to test and deploy infrastructure. So this could be, you know, vSphere, NSX, on-premise or in the cloud. This could also mean something like utilizing AWS or Azure to deploy infrastructure. And one of the key elements of this is utilizing what's called a pull request in Git. A pull request is really, you know, pushing a request saying, I made a change to the code. I want my peers to review it. And if it looks good, we're going to integrate it into the main release line code and push it out to production. So the pull request is really a request for review, and it does perform somewhat some governance around being able to provide permissions. Some people maybe can only do pull requests while others can approve and deploy pull requests. Finally, we have the concept of infrastructure as code. Infrastructure as code is just representing your infrastructure in flat files such as YAML or JSON. It's as simple as that. Instead of having a block configuration file or representing it strictly via the GUI, we now have a text-based way of very easily reviewing our configuration and using that flat file to deploy the configuration. And also this helps us bring infrastructure closer to the software development process. It might allow us to get closer to our customers in that area. And I think that's always a good thing to have closer collaboration between the application teams and the infrastructure teams. And down below, you can see some examples of some of the services. So Git, GitLab, and GitHub are examples of deployments of Git. Jenkins, GitLab continuous integration, and Circle CI are examples of a pipeline service or a CI/CD service that we could use to run through an automation pipeline. And then some infrastructure as code examples includes, some classic ones like Chef and Puppet, and some more emerging ones, including Terraform and Ansible. Briefly on the NSXT automation landscape, you can see here, this is kind of comprised of 3 different areas. We have on the left-hand side our integration points with some of the content management systems we have. So whether that's OpenStack, Kubernetes, VRA, VRO, or many of the things in our VMware Tanzu portfolio, we have tight integration with those solutions with NSXT's REST API. In the center, we have programming languages that we can utilize with our Open API spec. Python, Java. Down on the left-hand side, we have Golang, which is what Terraform uses ultimately. And then on the right-hand side, we have our configuration management solutions, so Power CLI, Ansible, and Terraform. Of course, today, we're going to look strictly at Terraform and how we can utilize that to automate our infrastructure. So why is Terraform CLI a good thing for NSXT? Here's some of the things that you look for in an infrastructure as code solution. So Terraform is agentless. We don't have to deploy anything to NSXT. Everything's done from the client side. So you deploy a single executable for Terraform on your client, on your workstation, and there's nothing to install in NSX or any other appliances necessarily to deploy Terraform out of the gate. So it's really easy to get started. It's declarative. So in other words, you make a statement about what you want your final outcome to be. I need a 3-tier application with 3 logical switches, 3 distributed routers, and these firewall rules. And then Terraform figures out how to translate that into what you want and deploy that into NSXT. Again, it's easy to start. There's a single executable that supports Linux, Windows, and Mac OS, among some other operating systems. So it is extremely easy to install and get going. Terraform has idempotency, which means you can deploy the same code multiple times and you're going to get the same result. I had a circumstance in the past where I wrote some PowerShell script to deploy a firewall rule, and the technicians that executed it accidentally ran it twice, and it created 2 sets of firewall rules with the same policy. So with Terraform, it's idempotent, meaning you're going to get the same result every time you run the code. It's only going to apply the changes that are necessary. I mentioned it's platform agnostic, and it's open source. It's on GitHub. It's maintained by a company called HashiCorp, and they allow official plugins like NSXT and vSphere, for instance, to be integrated with it. So why is Terraform, why is the NSXT provider for Terraform a good thing? It's supported by VMware. So if you have an issue, if you're running into a bug, you can call GSS and get support on that. So it's developed by VMware, and we're here to help if you have any issues. It broadly covers the majority of the day 2 actions. So if you have a use case creating switches, routers, the services within NSXT, or the DFW, we've covered most of those actions. Again, it's open source, so you can look at the code on GitHub. And it's integrated. So there's nothing separate to download to utilize NSXT with Terraform. You tell Terraform that you want to use it with NSXT, and it dynamically downloads the bits from the internet in order to utilize that integration. And let me stop here to see if there are any questions before I move on.
Yeah, I do have one question. So you mentioned it's supported by VMware. Do you know what level of support? Like, do you need SDK support to get access to that, or?
So my level of understanding, like your typical production support, will get you help with, any help finding bugs or issues. So support isn't necessarily there to write the code for you, but
Right.
to help with any issues with the integration. So if you had SDK support, you may be able to get a little more help than that. But generally speaking, with production support, you're going to get help with that integration piece. And if you find any bugs, we'll help fix them.
Got it. Cool. Thank you.
Yep, absolutely. Any other questions? Okay. So let's dive a little bit deeper before we get into the demo. We're getting close to the demo here, guys. So this is just a general flow of how Terraform integrates in an NSX environment. So you have the developer on the left-hand side, and they create what's called a Terraform template or a TF file, or multiple files for that matter, that comprise that intended state infrastructure as code. You run that through Terraform, and then Terraform does the rest. So Terraform is under the covers using, like I mentioned, the Golang SDK for NSX. And it's talking to the NSX manager and making, checking the configuration of NSX, looking for any necessary changes to realize the state of your intent, and then deploying those changes. Okay, and then last slide before I get to the demos here, before I set up the demo, just a very quick primer on Terraform. Don't feel like you have to know all this because I'll reinforce these during the demos. But generally speaking, you apply a three-step sequence to deploying code with Terraform. You do an init, which basically sets up the directory on your laptop with the necessary Terraform files to initialize the environment. It downloads any plugins that are necessary and make sure that the versions are in sync. And then you do a plan. A plan is basically going to look at your config and compare that to what's in the realized state in NSXT at the moment and look for differences and tell you, okay, I got to change this, I got to change that, I need to create this, I need to delete that. That's the planning phase. And you still, at this point, nothing has changed in the environment. You could go back and change your code, or if you realize that you're going to delete something you didn't intend, you can definitely make changes here before applying. And then finally, you do the apply stage, which is going out. Again, it's going to do sort of like a plan to make sure nothing has changed in the interim. And then it's going to apply your changes and tell you the result that it was successful or not. Maybe you have sort of a temporary environment where you are building something for a short period of time, or maybe it's for a container use case. You can use the Terraform destroy command to basically wipe out everything that you've defined in your intent. So Terraform apply to create it, Terraform to destroy to delete it. And I'll show you that in the demos. So Terraform calls providers are those, those plugins that we can utilize to integrate with our different platforms. So there's a provider for NSXT that I'm going to show you today, one for vSphere, one for Avi, one for VRA, and then there's some others, within the public cloud space. Of course, there's some for AWS, Azure, etc. Data sources are how you can pull things that already exist in NSXT into your templates. So for instance, I'm going to have a demo today where I have a data source of the built-in HTTP service. It's basically just a way of pulling in the configuration from an object that exists and then using it elsewhere. And I'm going to show you how to use that within a security policy. Resources are the objects that you create. So in my demos today, I'm just demonstrating the distributed firewall for the purposes of today's demo. So in that case, the resource is the NSXT security policy, and it has firewall rules underneath it. So you'll see that in a moment. And then finally, a very important concept is the concept of a state file this is what Terraform thinks your environment looks like, and this is what it uses to compare with reality. And so this is an important thing I'm going to talk about, going from a single developer use case to a multi-developer to an automated pipeline service. There's some important aspects to understand about how you maintain that state file and you share it across multiple developers. So more to come on that. Okay, before I get into the first demo, are there any questions?
Nothing in the chat.
All right.
Actually,
So
I have
here,
one.
yeah, go ahead.
Hey, the state file, when it how does it maintain that state file? Does it interrogate before it does a new deployment? Is it always there? Is it pulled periodically?
Nope. So again, everything's running from the client. Again, you wouldn't expect the client to be online all the time. So basically, every time you run that plan or apply, that's when it's comparing the state file. That's the last time it ran, basically, to what reality is at that moment. And so I'm going to show you an example where maybe someone cheats and changes something on the back end and how Terraform will catch that.
Okay, thank you.
Sure. Okay, so here's the first example. This is just a single developer use case. Again, this is how I would recommend getting started. You with your laptop running Windows, Linux, or Mac, creating a Terraform file, and then deploying it to NSXT. So let me show you that here. So you can see I just have a single file here, NSX.tf. And what I'm first going to do is do Terraform init. And when I do this Terraform init, you're going to see what it does here. It's initializing the provider plugin. So I'm going to show you the configuration file in a minute, but it noticed that I needed NSXT. So it actually in the background just downloaded that plugin for me, and it says it's successfully initialized. Now, when I look at the files that exist, there's now a .terraform directory. And this contains some plugins. So you're going to see here, it contains the NSXT plugin that was just downloaded here in the last few seconds. And there's a locking file to make sure that I'm not running Terraform more than once at the same time on the same state file. Okay, so let's look at the code here. Ask you to focus your attention in this first block. This is the provider block. Again, NSXT is our provider here. This is just initializing the configuration for your specific environment. So you can see I have a host, I have a username, and I have a password. Certainly there are some best practices I'm leaving out here in my demo around how to manage the username and password. There are better ways to do this. But for purposes of the demo, I'm just making it simple. You can see here I've commented out how we could use the principal identity feature within NSXT to use certificate auth instead of username and password. And I'm allowing unverified SSL because I'm just using self-signed certs in my lab. There's some other configuration things here. I wouldn't touch those unless you know what you're doing. I've never touched them. Okay, so that's the first block. The second block are my data service, my data resources. So you can see I'm importing. Data is the keyword. The type is NSXT policy service, and the variable name is HTTP. So this is a variable that I've created. And so basically what I'm doing is I'm importing the HTTP service that already exists in NSXT for the use in my firewall policy here, and I'll show you that in a minute. I'm also doing that for HTTPS. Okay, nothing too crazy so far, I hope. So this is where I've defined my resource, and you could have multiple resources in a Terraform template. I just have one for this specific example. And you can see here, my resource type is NSXT policy, security policy. So an example of another policy would be like a logical segment, for instance. So in this case, it's a security policy, and I'm calling it basic policy. And then these are just attributes of that security policy, or we used to call security policy in NSX the DFW section, right? That's what I'm showing you here. So we've got some attributes for that. And then I have two rules. I'm blocking insecure HTTP, dropping it, and then I'm allowing HTTPS, right? Pretty basic. Any questions about the configuration before I apply it?
Just to be clear, that resource there on line 22, the one you were just talking about, that NSXT policy, security policy, that comes from that module that it downloaded when you did the init, right?
Exactly.
Okay.
You got it.
And then one further clarification, Andy, at the very top, that top section, the host you're specifying is actually the NSXT manager, right? Not an
Yes.
NSXi host.
Yes, this is my NSXT manager.
Got it. Cool.
Okay. Oh, wrong way. So let's deploy that as code now. So if you recall, I already did my Terraform init, so I'm going to do Terraform plan. I got to spell Terraform correct. And so basically this is the first time it's running, right? So there's no state file yet. It's generating the state file for the first time. So it's basically pulling those objects from NSXT, and then the execution plan has been complete. It says I need to create something, and this is what I need to create. So anywhere there's a plus sign is something I'm creating. So I'm creating a new resource with these attributes and these firewall rules. And my plan, which is always a summary of what it's going to do, is I'm going to add one new thing. And that new thing is this resource I defined above. So now I'm going to do a Terraform apply to actually apply that. And while it's running real quick, I'm just going to show you my NSX manager here, so you can trust that I'm not doing anything tricky. So there's nothing there. It's an empty policy. And then before I apply, by default, it asks me, are you sure you want to do this? Yes, I do. And apply complete, one resource added. Hit refresh. Now you can see I have that new policy. Basic policy TAM lab with my drop HTTP and my allow HTTPS. So let's just make a quick change to the code. Let's just say TAM lab 2. Okay, I'm going to save that. And I'm going to skip the plan because Terraform apply does a plan before it runs, just to quicken things up here. Okay, and here's what it did. It realized my infrastructure's code changed. I'm going to do an in-place upgrade. So I'm not deleting anything. I'm just doing an upgrade, an update in place, and I'm just changing the display name. Nothing fancy. Of course, you could do something way more sophisticated than that, but just for this example, you can see it realized my infrastructure change, and it's only changing that one attribute. So yes, I want to do that. Okay, one thing changed. Let's go back here, refresh, TAM lab 2.
Sweet.
Okay, so remember that term idempotency I talked about? So if I try and apply this again, nothing's changed, right? I haven't changed any code. Let's see what it says. What do you think it's going to say? Nothing changed, so I don't have to do anything. That's idempotency for you. Let's do something sneaky here. We got a lazy dev who doesn't want to stand up TLS. Sneaking in a firewall rule. Okay, let's see if Terraform catches it. Think it's going to catch it?
Hope so.
I sure hope so myself.
Demo gods might think otherwise, but
Indeed. Naughty developer, I've caught you, and my intended state is no longer the realized state. So how do I get it to realize that intended state? I need to make a change. Absolutely. Let's make that change. There you go. I'm back to drop. Okay. So the final thing before I move on to the next demo, I'm going to do a Terraform destroy, because I'm going to use the next lab environment's going to use this one, so I want to clear it out. And so basically it's going to get rid of that entire policy, NSXT policy with the 2 firewall rules underneath it. You can see here, the plan is to destroy that resource.
So while you're doing this, take the use case that we had just before, right? Where the admin went and changed that rule from drop to allow. If you would destroy it and it's not in the same state, what would it do?
I think it'll still destroy it.
Okay.
Honestly, I don't know if I've tried that, but the policy object has not changed, and that's really what it's tracking. You're
Got
asking
it.
it to destroy it, so I think that's what I would do. It'd destroy it anyways.
Okay.
If we have time at the end, we can try that.
Break the lab, love it.
Okay, and now it's gone because I destroyed it. All right, so let's go on to the intermediate lab. And so in this case, the use case really is we're just taking the next step forward into utilizing Terraform. We've got multiple developers now that want to contribute to the NSXT policy. And so we're storing our infrastructure as code, Terraform files, and in GitLab, which is a Git repo where you can store files and it has version control, right? So I'm going to show you that in a minute. We have to add another element here, which is called a central backend. And in other words, what I mean by that is that Terraform state file that I was talking about earlier is no longer stored on Andy's laptop. It's stored in this case, PostgreSQL, so that it can be shared amongst multiple developers. I should say there's a bunch of options for backends. You could, there's some of them are on-premises things, some of them are cloud-based things. So you don't necessarily have to store it in Postgres. It's just the option I chose for my demo here. And you can see that TF state file is stored there. And that's ultimately the function that it's doing. In this case, there's really no automation yet. That's the advanced lab I'm going to show you in a minute. This is really just showing you how multiple developers could maintain infrastructure as code with GitLab or GitHub for that matter. Any questions? I thought I heard something.
I got a quick question, I guess,
Yeah.
in regards to the last demo that you were showing. So how does Terraform scale, right, from like if you're running this in an enterprise environment, you've got hundreds or thousands of firewall rules, and you apply a change, does it take,
It's going to take a couple minutes.
a lot longer? Yeah.
It's in the back end, it's really, doing API calls to pull out to compare with the state file.
Mm-hmm.
So I would say, let's say we have hundreds or thousands of firewall rules. It may take 5 minutes to apply that policy.
Okay, thanks.
Okay, so again, for this demo, I have GitLab running in my home lab. If you're not familiar with GitLab, it's very much like GitHub. It's this one's just free to run on-prem, so that's what I'm doing here. And I've got a new file here. So let me just show you that file before I go any further. This backend.tf file is the definition of the Postgres backend. So PG is Postgres SQL. And I have a connection string here. Again, I'm using probably not the best practice for production where my username and password are encoded in the connection string. But again, this is just showing how easy it is to switch from a local backend to a remote backend or a central backend. And then as far as the configuration goes in the Terraform template, let me pull that up. It's the same thing, right? So I've got the same configuration before, and let's just show you how you'd manage this slightly differently from something running locally. So in this case, I've initialized Git already because I'm connected to my GitLab repo. So that's where you see these .git and .gitignore files, and then I have the backend and the NSXT file. So let's do our Terraform init. In this case, this is an extra step I need to take just because I'm using what's called a workspace. I don't really want to go into here, but it's just a minor detail. You just switch to the correct workspace. And now it's going to do that initialization. It's downloading the NSXT provider, and it's initialized my folder. So you can see here, I now have that .terraform folder. But if I look at that folder, I'm not going to have a state file in there. It's just got some definition around where that TF state file is going to exist. So that exists in Postgres.
So real quick, got a question in the Q&A. How does Terraform handle multi-tenancy or multiple NSXT domains and folders?
Yep, so I'm going to actually get into that in the advanced lab. So I think if you can hold that question for now, and we'll circle back to see if I answer it for you later.
Oh, sure thing.
Okay, so I've initialized. Let's just do a Terraform plan. Oh, sorry. One thing before I do the plan, I want to do git pull to make sure I'm in sync with my repo, which it says I am. So I'm pulling the configuration down from GitLab. It says I've got the latest code. Let's do Terraform plan. Again, this is still in this demo. It's still being executed locally. I'm going to show you how when we use pipelines later, how that's not the case. Okay, let's just do a Terraform apply. This is exactly the same as last demo. So let's just get through the apply. Yes, and then like magic. My NSX environment should have updated with the intermediate policy for the TAM lab. Okay, so now let's imagine there's some other developer, and on his workstation, I'm going to use the GitLab GUI here to just edit this file. Let's imagine some other developer did this on their workstation, and they want to allow SSH. So I'm just going to import another service, and I'm going to create another rule, allow SSH. Okay, pretty basic. And I'm going to commit these changes. Now, nothing's changed yet. I don't have a pipeline in place. I don't have any automation in place. All I've done is updated this file. So I still need to do a git pull. And I've grabbed that new file. And then I can do a Terraform apply. And now I should apply that new configuration. Okay, it says, again, I'm doing an update in place, so I'm updating my security policy resource. And the only change it's detected is a new rule, which is going to allow SSH. Yes, I want to do that. Let's go back to NSX, refresh. Okay, so this is just a small step up from what we had last time. Does anyone have any questions before I get into the advanced lab? I think we need to spend the most time on that. Curious if anyone has any questions about what I've shown so far.
Yeah, just one question for me. Where, again, and maybe I just missed it, but where again did you define that Terraform should be looking at the database? I know I saw that you had that your connection string there, but where
was it? That was it. So one thing I've set up for my lab before I did the demo here is I had to install Postgres.
Yep.
And I had to create the database and allow access to that database. But other than that, Terraform set up the rest of it.
Yeah. What I'm wondering is, like, where in your directory structure, or do you actually specify the path to that back end, or does it just enumerate everything in there?
This connection string. So this is the server where I'm running Postgres on the same server I have my GitLab running on.
Sure.
And this is the database name, NSXT-TAM lab.
Yeah. No, I guess maybe I'm not asking the right way. And if I don't get it this time, we can talk at the end. I'm just wondering, without some way of you specifying that in your environment, wouldn't Terraform just create a local state file?
Mm-hmm. Absolutely. So the default action is to create a local state file, and if you have a backend configuration like this, it's gonna apply that state file elsewhere. So a common use case is actually to go from the basic lab to the intermediate lab, where you're doing it locally and you want to have multiple developers involved. So let's say you already have a local state file. Terraform will automatically migrate the state file from local to the remote backend.
Oh, cool.
Yep.
Awesome. Well, thank you.
Sure, absolutely. Any other questions? Okay, so let's get into what I think is truly what most people would desire in their environment is an automated GitOps pipeline. So let's talk through what this means. In this case, I'm just doing something a little different. Instead of using GitLab, I'm using GitHub. And my CI/CD pipelining tool of choice, at least for this lab today, is Jenkins. And again, I'm still using Postgres to store that state file. So imagine a use case where you have multiple developers who are defining Terraform templates for NSXT in GitHub. And instead of running Terraform locally for the developer, all they're really going to do in this case is make updates to those Terraform templates and do a pull request. And that pull request is going to trigger a webhook. A webhook is basically just a REST API command sent from GitHub to Jenkins and says, hey, someone made a change. You should take a look at that. And so Jenkins say, okay, I received a webhook. Someone did a pull request. And then it's going to run through the pipeline where it's going to actually execute Terraform. And so there's two steps to this automation pipeline that are important. The pull request is going to do a Terraform plan. So it's that phase before it takes any action. It's going to look at the plan, or it's going to calculate the plan, and then you're going to have an opportunity to look at that, see if your expected result is there. And then when you do a merge of that pull request, merge that pull request into master, that's when it's going to run the full pipeline, which is going to do the init, the plan, and the apply, and push those changes to production. Okay? So to make it even a little bit more extravagant, I have 3 NSX managers here. So this is a demonstration of being able to apply Terraform across multiple NSX managers. And I've created a hierarchy of firewall rules. So I have firewall rules that apply strictly to that site. Then I have firewall rules that apply to the region. So you can see here, within region 1, I have site 1A and site 1B. And within region 2, I just have a single site, site 2A. And then finally, I have global policy, which applies to every site. And that's what I'm going to demonstrate for you, is how I can make a change to the global policy, and then it'll push that configuration to all the NSX managers. Okay, before I get into the demo, any questions about the design of the lab? Okay. So let's look at GitHub. Let me make sure I'm still logged in. So this is GitHub Online. This is the free SaaS version of GitHub. And I'm introducing a new concept here I haven't talked about before called modules. And module is just like really a reusable code. Think of it that way. So within the modules directory here, I have the NSXT policy that's going to pertain to all sites, that's global. I have NSXT policy that's going to apply to region 1 and region 2. And I have ones that are going to apply to the specific sites. And everything is organized by folders. Terraform uses folders for this multi-tenancy approach. I think that's the question someone brought up earlier. So each one of these folders comprises that Terraform template that would apply to these different sites. And so what I want to show you today is how I have this global.tf file with a very basic policy in it, and how when I make changes to it, I can apply that across multiple NSX managers. So without getting too deep into what modules can do, let me just show you an example of how you would apply that module. So basically, I just say, if I want to utilize that module within my specific instantiation of NSXT, all I need to do is tell it where that folder is, and then it'll inherit that policy and use that policy within that specific provider. So hopefully that makes sense. I know it's a little bit more complicated of a design, but if you focus on the fact that this is demonstrating how I can deploy policy across multiple NSX managers, I think it'll make sense. Any questions about the organization, the structure of the Terraform files in this case? Okay. So let's go to the global module here, global.tf, and I'm going to edit this file within GitHub just to make the demo a little easier. And I'm going to rename this to TAM Lab, Global Policy TAM Lab. So every site today, let's look at that before we apply it to. I'm using NSXT's federation capability here just to show you all 3 sites. Terraform's not integrated with the federation capability today, so I'm talking to each individual NSX manager. And you can see here I have a global policy with a single global rule. So again, I am making a change to that Terraform file, and I'm going to create a pull request. That's what this is doing. Create a new branch for this commit and start a pull request. Okay, I'm not gonna put any comments in there. Okay, so now I'm gonna jump over to Jenkins. So this is the graphical interface for Jenkins. And if I'm lucky, this will work. It's not working. Let's see here. Let's try this merge. Okay, let me try one thing here. Sorry about that, guys. Let me see if I can get this working.
Oh, no problem.
I got through 2 demos with no problems. Okay, so here we go. So I did a pull request, and during my troubleshooting there, I missed one thing. So let me just show you an old one here that I did an hour ago. So when you create a pull request, that's sending that webhook trigger from GitHub to Jenkins, which is our CI/CD pipeline solution. And since Jenkins knows, okay, this is not a merge into master, this is a pull request, it's going to do these steps. It's going to check out the code from GitHub. It's going to do a Terraform init, a Terraform plan, but it's not going to do a Terraform apply. So you can see here, let me just show you an example. I'm doing Terraform plan, and this is the reverse direction because this is the one I did an hour ago. It's changing that display name. And it's saying when you're ready, you can do a Terraform apply and it'll execute that code. Okay, so let's look at, this one is actually still running. This is the merge into master that you may have seen there. I did it kind of quickly. And it's going to check out my code. It's doing a Terraform init on each one of the sites, downloading the NSX plugin, making sure it's got the latest one. It's doing a Terraform plan. You can see everything's green. It's going to change the name from Global Policy to Global Policy TAM Lab. And then ultimately, see, this took 33 seconds, Steve, to apply to 3 sites. It's going to go out and add that change. So now if I go to NSXT and I refresh here, you can see this is site 1A. has now been changed to global policy TAM lab. Let's just look at one other site. Let's look at 2A. The change should also be applied there. And there it is. So this is one method you can use to synchronize policy, whether it's distributed firewall policy or maybe consistent names for logical segments or routing topologies across multiple sites. And again, in this case, we utilized Git to store our Terraform files. We utilized Jenkins as our pipelining mechanism to actually execute the Terraform executable and run the Terraform templates and store that remote state in the Postgres backend and ultimately synchronize those sites with the same configuration. Any questions about this demo?
Maybe I missed it, but did you talk about what's required to set up the integration between Jenkins and Terraform? Is it just like a plugin or something?
So Jenkins really doesn't know that Terraform's there. So in other words, in this case, let me go back to my slides here. So in essence, Jenkins is a Linux server, and it creates a directory every time it runs a pipeline. And actually, I could probably just show you the pipeline itself.
Mm-hmm.
But basically, it's just running shell commands. So I think that's probably the easiest way to answer your question, is just to show you the Jenkins file. So what Jenkins is doing, when it downloads the code from GitHub, it's looking for this Jenkins file here to run the pipeline. It's pretty basic in what it's doing. So you can see each one of those green dots here is called a stage. And so what it's doing here, this is a built-in Jenkins function called clean workspace. And then it's checking out my code from GitHub. So the setup here was really, you got to tell Jenkins where to grab the code from. So there's a URL to get to GitHub and some credentials to get to GitHub. But other than that, it's basically all performed with this Jenkins file. So it does the checkout, it does the init, which you can see here. It's just a shell command to change directory to that site, and then do init, and then do plan. And then there's a decision branch here that if the branch name equals master, do the apply and show. Show is really just showing back what the changes were. So if it's just a pull request, it's not going to meet this criteria, and it's not going to do these last two steps.
Okay, so I guess on the Jenkins server itself, you have to have the Terraform client, right?
Yeah. So you would have to log into that Jenkins server and basically do. Let me show you here. You would do. This is an Ubuntu server. Hopefully, you guys can see that.
Yep.
Apt install. I need to do sudo Terraform.
Okay, got it.
I guess I did it that way. I think I did it that way. It's probably Terraform something, Terraform CLI. But it's as simple as just installing Terraform, and then you can. The interesting thing about this is trying to think where executable is. I'd have to look for it. But in essence, what it's doing is every time you run the pipeline, it creates a new folder within Jenkins, and it just runs the pipeline over. And so you're basically guaranteed to have the same result every time because it's starting from a clean slate. It's starting from an empty folder. It grabs the code from GitHub, and it basically does an init. So it downloads all the code from Terraform, does the plan, and does the apply. So you basically have a repeatable process that you can be pretty comfortable as being run exactly the same every time.
Very cool.
All right. Any other questions or anything anyone wants to try while I've got the lab working here?
Bill
All right,
wants to break it. To destroy your lab.
All right, I just have a couple slides here, then I have 2 more slides, and then we can wrap up. So some suggestions for making this enterprise ready. Circle around that state file. We need a central location to store that state file. It should be encrypted because it may contain credentials depending on how you're utilizing it. So certainly it should be stored encrypted at rest and encrypted in motion. And it's important to have that central location or that backend location have the property of locking. And so this is something you should look into if you're interested in Terraform on the Terraform website. So locking is going to guarantee that only one person is executing Terraform at the same time. So maybe it's 2 developers just doing it manually, or it's the pipeline doing it automatically. You don't want 2 Terraforms trying to talk to the same NSX manager at the same time. So locking is important. And then finally, there are a number of ways of doing this, but you should certainly make sure that you are securing your secrets properly, not storing your username and password in GitHub. That's a bad practice. So there should be a mechanism for checking out that credential and injecting it into your Terraform code at runtime so that you've got a secure and compliant environment. So certainly this isn't an exhaustive list, but these are things that I found would be important to making this enterprise ready. And then let me just flash this screen on here. So these are some links to the official NSXT Terraform provider, the NSXT Terraform provider that's hosted on GitHub. So our developers are making changes to this daily. They're integrating new changes into it, and that's what you're going to see on GitHub. So if you want the latest and greatest code, you go to GitHub. The downside of that is if you want to call support, you really need to use the official provider. So the GitHub code is community supported by the developers potentially or the remainder of the community. Whereas if you're using that official provider, that's where you can call GSS. There's a Terraform demo on YouTube already from the product management team. And then there's also a blog. So go check out those resources if you want more information, or certainly reach out to me. I'm happy to provide some direction and help you guys on your journey to utilizing Terraform with NSXT.
Awesome, Andy. Anybody got any questions or comments? This has been really good.
Yeah.
How long did it take you to prepare this? Just curious. How many hours?
Not too long, honestly, because most of this I'd already been doing with my customer. The basic and intermediate one, I just started from scratch, honestly, last night. So it's really not that hard once you get going.
Yeah.
Once you get those pieces plugged in together, they're talking to each other, it's off to the races. It's pretty easy to get started.
Yeah, very cool. All right, last call. Anybody got any final comments or questions for Andy? Or I'll let you go. All right. Well, thanks again, Andy. Hope everyone has a great rest of their week and a good weekend. Take care.
All right, take care. Thank you.